Good afternoon, ladies and gentlemen. Welcome to day 4 of the live Q&A session. So we're just going to give it a few moments just for everybody to sign in and give everyone a chance to get involved. And then we're going to dive into a load of very, very interesting topics today. We've got some great questions for everybody. So welcome to all of you that are signing in. We're just going to give everybody a chance just to sign in and say hello. Hi, Jack. And we've got a lot of topics basically from what we covered yesterday, where we finally got airborne. We had a great session yesterday. But today we're going to be going into a load of really, really interesting topics that loads of people have given me some really great questions, and I said that I will answer them and also allow you guys here to come and join me and get involved as well. So hi to all of you signing in from wherever you may be in the world. We've got Alessandra here. Hi, Michael. Hi, Jack. Agnieszka, hey, how are you? Hope you're keeping well. And to Barbara and Isabella. So we've got some questions we're going to dive into. We're going to be talking about quite interesting ones today. We're talking about anti-ice. We're talking about IRSs. We're going to any questions you may have with regards to getting airborne checklists and so on. So please do ask. So I've got a question here straight off the bat from Jack. He says, hi, Ben. Thanks for all the content so far. Please, can you clarify the transition from when to disconnect the ground power to when and how you'd start the APU in order to start the engines? Yeah, that's a good question, and we did kind of gloss over that a little bit yesterday. So when we're talking about APUs and air starts and so on, so when we're on the stand, generally we'll have the ground power unit plugged in. And that's going to allow us to supply the aircraft with AC power during the turnaround. We could start the APU straight away, but if we do have ground power, it's a much better way of doing it. It's much more environmentally friendly. It's much quieter for the surrounding environment. So ground power will be on. As a general rule, once we're getting into a position during that pre-flight setup that we're kind of thinking about running the before start checklist, we're thinking about doors and pushing back, that's generally a good time to start the APU. Now, the APU does take a couple of minutes to start. So to start it, all we do is pull this. Oh, no, we don't want that. Let me just zoom in a little bit here if we're talking about APU starts. We're going to move this out and forward and let go, and that will start the APU start cycle effectively. So generally, if we're starting APUs, generally once we're about to close the doors and think about pushing back, because it does take about probably best part of a minute to start the APU, and then we need to allow a minimum of a minute, ideally 2 minutes, to allow the APU to stabilize before we start demanding air from it, because it just allows the EGT temperatures to stabilize. And if we start taking air from it immediately, it can just create some excessive temperatures that can reduce the life of the APU. So hi to all of you joining in. It's great to see you all. Great to see you in the group over the last few days as well, with some great questions. And we've got a great one for you tonight as well. A really, really good one tonight that I'm really looking forward to going into with Petja and myself. Sassy, hi. Do we use a landing, taxi and strobe lights during the day? Yeah, good question. We do. So we would basically, if we're taxiing, these should be on. So whenever we move, before we start taxiing, our turn off lights and our taxi lights will come on. Now I'm going to see if I can change the view here for you. So our taxi lights are here on the nose. These are our taxi lights, and these are our turn off lights just here. And they basically illuminate the area around the aircraft. So the turn off lights are at an angle, about 45-degree angle with quite a big beam width to illuminate, particularly at nighttime, this area out here and this area out here. And obviously the taxi light is on the nose, and that shines underneath in front. And it, from a taxiing perspective, it gives you a big swathe of light in quite a big arc that enables you to taxi. Obviously really important during nighttime taxiing, but also during day, because it enhances our visibility. So from an SOP, we would generally have these on. Now, when we come to line up, we would generally, as an SOP, and this can be company dependent, we would generally put on our retractable lights and our fixed landing lights. Now, these are the mega bright ones that will come on. Now, the retractable lights, if you haven't seen them, I actually did a reel on my Instagram channel where I actually get a close-up footage of where they're housed, how they come out, and they're actually housed on the belly of the aircraft. And by turning them on, they come down and they turn on. And these are the fixed ones, which are next to the turn-off lights, and these are mega bright. and we would use that for landing and takeoff. So we'd put all of those on. And the strobe lights go on when we line up on the runway. That's a standard SOP. Whenever you see any aircraft lining up on an active runway, you're going to see the big bright white lights flashing. Again, it enhances our visibility. So that's generally why we would use the lights and what we would use them for. David, any tips on memorizing memory items? So yeah, memory items are part of the checklist that we would run, and the kind of grind into your memory right from the sim type rating is something we teach the cadets and drill into them, and they're examined on. And there's no kind of easy way. There's quite a few of them, and it's just a matter of repetition. And sitting here in the sim can be really, really useful. So for example, if we had an engine fire, we would call for the engine fire memory item. So you can practice and maybe have the QRH, have the actual checklist next to you. If you don't have the sim available, or you're out in a hotel somewhere, or you're driving, you can actually do it from your memory. But the important thing, what I've learned from when you're trying to memorize stuff, is if you're not sure, don't guess. Have a look at the check, have a look, and go, oh yeah, it's that, and then run through it in your mind again. Because if you guess and you get it wrong, you're reinforcing the wrong thing in your mind. It's an interesting way the brain works. But if you're memorizing it, have that with you and then practice. So if we had it, I'll give you an idea now. So let's say we had say we're flying and we have an engine fire. So it'd be engine fire memory items. So it's auto throttle, if engage, disengage, and we would disconnect the auto throttle here. Thrust lever, engine number 1, confirm close. So we would confirm it with both pilots to make sure we've got the right engine. They would confirm it, and then we would gently close the thrust lever. We're now flying asymmetric. Engine start lever, engine number 1, confirm cutoff. We'd confirm it. This is a really important one because if we get the wrong engine, we're now really up the creek without a paddle. So we very carefully take our time to confirm it. Confirm cutoff. That now shuts off fuel and ignition to the engine. Engine fire switch, engine number 1, we're going to confirm that. Again, take our time. We're going to pull it. That's going to, again, cut fuel, cut ignition, close the APU, close the bleed valves, shut off hydraulics. It basically isolates that engine from all of the systems. And if the red light is on, indicating that there is a fire, we would rotate it and hold for 1 second to discharge an extinguisher in there. And then we'd wait 30 seconds. If the light was still on, we'd discharge another. So all I would say, David, is if you're memorizing memory items, practice. But, a great thing to do is if you're on your own, close your eyes or sit in the sim, even better, run through it. And if you're not sure, don't guess, have a look again, start from the beginning again, practice, and it will just reinforce it in your head. Hi, everybody signing in. Great to see so many of you live again. Hi, Dodsy. Hans, how are you? Jurgen's here as well. Good afternoon from Ostend. Good afternoon. Fly over you quite a lot coming out of Stansted. We often get a great view of Ostend as we start heading down towards Italy or, Germany. We go right over the top of Ostend, so get a good view of that. Hi, Emily. Good morning from Texas. Good morning to you. That's an early start for you. So, Robert, hiya. On departure, and when light, the flight director can command greater than 20 degrees. Why does it do this? Since we are limited to 20 degrees, the speed creeps up and feels a bit out of control. So what Robert's saying there is a good question. So as we get airborne, Boeing recommend that we limit our pitch attitude to no more than 20 degrees nose up. And that's really for passenger comfort. 20 degrees is pretty steep. And if we start going beyond that, it starts getting kind of really steep. It starts getting to that realm that you see at air shows. When Boeing display the Max or the Dreamliner and they get airborne and they just go almost vertical. Great fun for us in the front, not so fun maybe for those in the back. So 20 degrees is the limit. Now, when we're light, what Robert was saying there is the flight directors, if you're light and you've got, sometimes we're positioning aircraft maybe, you can get to a point where actually the flight directors will want to pitch you up to maintain a speed. Now, when we're climbing away, just to give you an understanding of what the flight directors are trying to do, is obviously we set takeoff thrust, and then the pitch flight director, which will be on here, the horizontal one, will pitch the aircraft to maintain a speed. And that speed is generally V2 on normal engines, normally about V2 plus 20. Now, V2 is our single engine takeoff safety speed, and that's 146, and that's what we set here. Actually, 146. And it aims to achieve, with 2 engines, V2 plus 20. So it aims to achieve generally 166 in this example, up to a maximum of plus 25. So maybe 171, but say 166. And that's all the flight directors are trying to do. So it will try and pitch you up to maintain that speed. But if you're very light and you've got a relatively high thrust setting on, you might get to 20. You might get to 20 degrees and see that actually the flight directors are still pitching you up beyond that. Boeing's recommendation is you look through the flight directors, you stick at 20 degrees. What you will find that will happen then is the airspeed will gradually start to increase because we've got too much thrust for our pitch attitude. And that's fine. It's not, nothing bad's going to happen. I remember once when I was years ago, we were positioning an empty aircraft from Stansted to Pisa. It was at the end of the winter and we ended up moving aircraft out to the summer bases. So we just flew an aircraft empty. And back then, this was years and years and years ago, there was a rule, and I never understood the rule, but it was a rule that if you were empty, we would have to go full thrust. I know that sounds crazy, but I know we weren't the only airline doing it. I know Virgin did it as well, and I know there's a few other airlines that used to do it. And there must have been a logic behind it, but I don't remember what that logic was. So not only were we now light, we now were going full beans, full power. And I remember we're on runway 04, we're taking off down the other end of the runway. And we got airborne within a few seconds. You know, when we added thrust and hit TOGA, the kick in the back was insane. You know, this aircraft is designed to be happily lifting off almost an 80-ton aircraft on one engine. And here we are, half of that weight with 2 engines at full power. So we get airborne. And, you know, I was flying and we get it to 20 degrees very quickly. And the airspeed is still accelerating. We had to keep it at 20 degrees. But even at 20 degrees at light, we were doing the old Dover departure out of Stansted, which leveled at 5,000 feet. And we were climbing up so rapidly. I remember we were halfway down the runway and ATC to the tower saw us going and said, just to confirm, you're going to level at 5,000 feet. And we're like, yeah, Roger. And without a shadow of a lie, we leveled off. We got into outer quiet and started leveling off before we got to the end of the runway. So from a standing start at 04, we got to 5,000 feet before we got to the end of the runway. It was insane. And the aircraft was accelerating the whole time. You know, when it's light, the power to weight ratio on this is quite something. But thankfully that rule has changed. We can now derate the engines to its max and make it much more controllable. But it was one hell of an experience. So yeah. Hey, Sasha, how are you? Vincent, how are you? So I said, I have a question about the APU bus switching, which I don't think was covered, as I always seem to lose power when switching the electrical bus. So I think my sequencing might be quite correct. Okay, so I know there's a few people have had a few issues, I think, with bus transfers. So I just go onto the overhead panel here. Now, if we're on stand now, obviously we're at the holding point. I assume we're starting engines, or maybe we've just started engines. So the APU would be on, and the APU would be powering the electrical system. Now, the flow that we do is the very first thing we do once we've said goodbye to the ground crew, we've double checked they're clear, is we go into our before taxi flow. And that is to put the generators from each engine on the buses, so on the electrical power. So it powers the aircraft. So we move this to on, we move engine number 2 to on. And if you do that right, you should see this light come to blue. And it tells you that the APU gen is off the bus. So the APU generator is not on the bus. The bus is basically think of it as like a simple way I like to think of it is like a strip of metal that the main power is going into, and lots of other little wires come off that to go to different systems. So that's like a bus bar. And we're basically connected. We can either connect the engine generators, the APU, or the ground power to that bus bar. And we transfer it. So we put the engine generators on. That should be bright blue. And then we turn the APU off because we no longer need it. And that light should go out. And then we're now powered by the engines. And that should work. So Vincent, if that's what you're doing or you're not sure, let me know in the comments and I'll see if I can catch up on that again. Hi, Barry. How important is it the pressurization and cabin staff when you just start when you're just flying freight? So if we're flying freight, so if you're a cargo operator or maybe we're flying empty, which we do sometimes. I actually had to. What happened? I was on standby one day, not that long ago, probably about a month or so ago, maybe a bit longer. Got a phone call saying, "Hi Ben, listen, we need you to position up to Edinburgh, and then when you get to Edinburgh, you're going to take a brand new empty Max that was there and fly that back to Stansted." And we're like, okay, fair enough. So I rocked up at the airport as a to log in as a passenger for the scheduled flight to Edinburgh. Got off at Edinburgh, and as we're walking to the aircraft, we got a phone call from ops saying, actually, it's a change of plan. One of our aircraft in Prestwick. So for those of you who aren't familiar, Edinburgh is up on the kind of the east side of Scotland, and Prestwick's near Glasgow on the other side. And that was a base. And one of the aircraft there had gone tech, had broken down. We now need you to fly this MAX empty to Prestwick and then hang around for the other aircraft to be fixed so you can fly yourself back to Stansted. So we got new flight plans, we uploaded the fuel and everything. And we flew the airplane empty to, from Edinburgh to Prestwick, which was all of about, I think, 12 minutes or something like that. It was pretty quick. But yeah, so when we're flying empty or with just freight, we would still pressurize the aircraft in exactly the same way as we would do if passengers were on board. So we don't treat it any differently. So we would set the pressurization panel up here to the cruise altitude, the land altitude. We make sure the bleeds are on, packs are auto, and we set the temperature correctly. And it's important that we do, because we got to protect ourselves, even if we're unpressurized, because we don't want to be flying around unpressurized. A, we need our oxygen masks on. B, it'd be very uncomfortable on our ears. So we generally treat it exactly the same if we're flying cargo as we would do if we're flying passengers. No, well, hey Lulu, how are you? Hey Oren, Paul's here, nice to see you. Uli as well, Claudio. Hi John, hi Brian. So Linus, hi. Sometimes also when we want to remove the GPU cable to connect pushback trucks, most happens in the Airbus where the cable is in the middle, we can ask the pilots to start the APU as well. Yeah, so sometimes what you'll often get is when we're kind of getting into a position, we're on stand and we're getting into a position ready to push and start, you'll find that the ground crew are also doing their own checks down below. And one of the things they want to do really is get rid of everything that's connected to the aircraft. Like, in fact, it's like an umbilical cord. It needs to disconnect from that. So what you'll sometimes do is, obviously we're quite high up, but the fuselage goes right down below us where the nose wheel folds into. And to get our attention, the ground crew will often like bang the side of the fuselage. So we're kind of finalizing our checks and you'll hear like a bang, bang on the side of the fuselage. And you'll look out the window, sure enough, they're kind of doing this symbol. And that's the standard symbol to remove ground power. And what we will do at that point, we'll either give them a thumbs up or a thumbs down. So if we've got the APU up and running and we put it on the bus, so we're now being powered by the APU, we can go, yep, disconnect. And they will then disconnect the ground power. It's one of their jobs done. However, if we've just started it, or we haven't started it yet, we give them a big thumbs down. Just say, look, just stand by. We're just starting the APU up. And yeah, but the ground crew, they could give us a ding as well. They have communication line from a headset below that can speak to us, and they can call us. They can press a button, and it goes ding, and we would say, hey guys, how you doing? And say, look, is it all right to disconnect the? Can you start your APU so we can disconnect the ground power? Yep, no worries. So yeah, that can happen as well. Michael, hi Michael. I have a couple of questions regarding the engine display. If anyone can help, is it normal for the EGT temperature to be different by a couple of degrees? Is the fuel flow usually to be slightly different? And also, is it normal for the wing fuel tanks to be different? Like one tank is 7.3, the other is 7.4. Yeah, it's a good question. So what you're saying on there is when we're flying, or when the engines are running, if I just bring this up, is it normal for them to be slightly different between the engine? And the answer is yes, particularly as you get onto older aircraft, because it's quite normal. Like, for example, remember we go back to day one, we spoke about one of the first things that we do when we come onto the aircraft, we turn left, we open the door. One of the first things we do is we pick up the tech log. And, you'll sometimes see that they've done an engine change, which is something they can do pretty much overnight. And they take the old engine off and they'll put a brand spanker on because it's reached the end of its life and it needs to be reserviced. And they put a brand new engine on it. And when you do the walk around, sure enough, there's a gleaming brand new CFM 56 hanging off one of the wings. But the other engine is an older engine. And, so there can be quite significant age differences between the two engines. So it's not uncommon to see different EGTs, different fuel flows. The M1s will be the same because the EEC, the electronic engine controller, the brains of the engines, will command the N1 to be the same. But what exhaust gas temperature and fuel flow that is can be different. So if you look on here, we've got EGT of one of 552, the other one's 547. So that's actually quite normal and very realistic. So yeah, if you see that, that's doing it. Hey, Giuliano. Hey, Dan. How are you? Good to see you here. Tom. Hi, Tom. Hi, Ben. Do the thrust reduction and acceleration heights in the CDU need to set the required procedure? Also, any difference between those settings and the cutback quiet climb system? So if we go into page 2 of your takeoff page, so what Tom's talking about in here is in here there are standard acceleration heights, thrust reduction heights, engine out acceleration heights. Generally, you don't need to update it. Normally, this is pre-populated. What I always do is check that the thrust reduction is at 1,500 feet, because when you get airborne, and the thrust should reduce from the takeoff M1 to climb thrust at 1,500, and we set that in here at 1,500 feet. But the rest of it in here is kind of irrelevant, the acceleration height, because we're not actually going to be using the FMC for any of that. We're going to be doing that manually using our speed bug. So there's no harm in putting it in. And if you're actually flying for a real airline, the SOP might be to actually do it, but you don't have to do it. And that's down to you. So in Butter Airways here, you don't have to do that, but that's a good question. Hi, Evie. I know, where's the Butter Airways livery? So Butter Airways is something that is a long story, but yeah, I'll tell you about it. So as the retractable landing lights provide some drag and extra fuel burn, do you usually turn them off below 100? Yeah, there's a good check. Good question. So as I think it's Ralph mentioned on there, the retractable lights. Now, let me just see if I can show you those outside. So yeah, here we go. You can see the retractable lights. They hang down here, and when we turn them off, they fold up. And as an SOP, the airline I actually work for actually did some maths, and the airline I work for has a lot of 737. We have a lot of flights a day, over 3,500 flights every single day, which is bonkers. And with that amount of flights, they realized that they did some maths with Boeing, and these retractable lights here, when they extend down, naturally they're going into the airflow. They do cause a tiny amount of drag, not a lot. But when you times that by 3,500 flights a day, the fuel saving of turning those off as early as possible start to add up into quite significant numbers. So as an SOP, what we do in Butter Airways is once we get airborne and we go positive rate gear up, the pilot monitoring will raise the gear, and then they will turn the retractable lights, if I can on here, off. Because we no longer need them. We've got our fixed, very bright landing lights on. We've got our turn-off lights on. We've got our position lights. We've got our strobes on. So these aren't really serving any purpose at this point. So we actually turn those off as soon as the gear is up. And that reduces, and it actually saved a ridiculous amount of fuel every month, every year. So we turn them off then. Years ago, we used to turn them off on the 10 checks. So as we go through 10,000 feet, we do the 10 checks, which is something we're going to be looking at in the future. And we used to turn it off there, but by turning them off straight away, actually saved a bit of fuel. It's a good question. Hey, Abdul, how are you? Only here for a couple of minutes as I'm drowning in work. Oh, sorry to hear that. My question has nothing to do with your current course, but a peripheral one. What sources would you use for training in radio communication? Let's have a look on here. And you used to fly in Liverpool in a Class D airspace to communicate the aviate, navigate, communicate, resulting in my membership being poor. So radio communications, there's lots of sources on that. If you're in the UK, the CAP 413, I think it is off the top of my head, the civil aviation publication on radio communication. There's some really great information in there, Abdul. So if you go and search for the CAA radio communication guide, I think it's CAP 413 off the top of my head. It gives you some great standard RT. So it's a really good thing to have a look at. Hey Shabib, what is the purpose of 2 CWS buttons below the autopilot switch? That's a really good question. Let's have a look here. So if I go, maybe this one's a better view. So what Shabib's asking there is we've got the autopilot. So we have 2 autopilots. We have Command A and we have Autopilot B. And below that, we have CWS A and CWS B. Now, these are not often used. Now, control wheel steering is what it stands for. And it effectively turns the 7.3's flight control system into a bit like a fly-by-wire, it's a basic Airbus system. So if, for example, in the Airbus, if the airbox is all fly-by-wire, so you've got a little side stick that's electronically connected to the controls through a flight control computers and so on. So when you're airborne, you could pitch up to 20 degrees, you could roll 30 degrees at bank, you could let go, and it would keep it there. The autopilot will keep it there. Even though the autopilot's not engaged, it will keep it at that attitude and pitch and angle of bank. In the 7.3, I like the 7.3. It's kind of basically a giant Cessna. It's just the controls are connected directly via cables and hydraulics to the controls. You know, whatever the aircraft does is a result of what you've done effectively, and that adds like a sense of satisfaction to me when you're flying it. But if you go into control wheel steering, what you can then do is that your control column, obviously we normally manipulate the autopilot through the mode control panel. So if we want to turn left, we would use the heading bug. But by going to control wheel steering, what we're doing is effectively using our yoke now as a way of inputting information to the autopilot. So if I went into control wheel steering and rolled on, say, 20 degrees of bank and then let go, if I did it without the autopilot on, it would just start probably doing a spiral descent and start increasing the angle of bank. But in control wheel steering, if I have a pitch attitude of, say, 10 degrees and I roll on 20 degrees of bank and let go, it will stay there. So you might ask, well, why? It feels a bit weird when you're flying through CWS. It feels there's a bit more resistance. So it's not something you want to be flying in. So you might ask, well, why would you use it? And one of the reasons we might use that would be in severe turbulence. So if you're flying around in severe turbulence and you're bumping around, what we can do is take it out of the autopilot mode and put it in control wheel steering. And that means it will just hold the pitch attitude of, say, 3 degrees. So we're up in the cruise and the wings level. And what that does is enables you to ride the turbulence. Because in severe turbulence, say you get a big pitch up, what the autopilot's going to do is it's going to try and maintain your altitude. So it's going to fairly aggressively pitch down, and then it can go the other way. And what you can find is the aircraft is pitching up, pitching down, and you can overstress the horizontal stabilizer and cause a lot more stress on the aircraft. Whereas if we sacrifice the altitude, so we don't hold the altitude anymore, we tell ATC we can't hold it, go to control wheel steering, it's going to hold the attitude. And when you get a big pitch up or, you know, big updraft, it's just going to ride it like a boat on a wave and then come back down with the wind and go back up again. And that's much more gentle on the aircraft. So that's one of the few times we would ever use control wheel steering. That's a good question. Yeah, Michael, crossing an active runway, strobes go on. Absolutely. Hi, Randall. Hi, Gordon. Hi, Martin. Question about the TOGA button. During go around, if you click TOGA once, then it will not give you the full thrust. You will get the full thrust if you click it twice. Does that apply when taking off? Clicking TOGA once. Good question. No. So yeah, your knowledge of the 7.3 is obviously good. So the TOGA buttons, as I said, are down here. These are the takeoff go around buttons, and these activate either the takeoff or the go around mode. So on takeoff, no, one push, it will give you your takeoff thrust effectively. It'll go to the N1 that we've calculated on there, and then go to arm once we get past 84 knots. So that allows you to add thrust if you need it. So if you do press it, if your flight directors aren't on though, say you forgot to say they're not on and you press TOGA, you'll still get takeoff thrust, but if you press it again, you will then get your flight directors pop up automatically. So it does do a few other things, but not quite the same as on the go around. Yeah, and hi Jan, which altitude do you turn off the landing lights? When do you set engine control to off? When do you allow service? Is there a max climb rate? Okay, so when do you turn the landing light off? So the landing light goes off as when we turn these off. So once we get a positive rate of climb, we get airborne, gear up, pilot monitoring turns the retractable lights off to save the drag, which we spoke about a moment ago, and they turn the taxi light off. The taxi light will also automatically turn off as soon as we go gear up anyway, but it's just a way of tidying it up. So that's the first question. When do you set engine control to off? Do you mean the start switches here? So the start switches, if you mean those, we turn those off during the after takeoff checklist. So once we do the after takeoff checklist, we turn these to off, and that means that it just turns the ignition and off in the engine, because the engine's got a huge amount of fire in the combustion chamber that's igniting the fuel and air coming in. We don't need it anymore. So that's when we would turn those off. And when do you allow the cabin service? So that's another good one. So we generally, once we're above 3,000 feet above the ground, so in Stansted above 3,350 feet, generally we do that at the end of the after takeoff check. So once we've done the after takeoff checks, we would normally, pilot monitoring would say to pilot flying, happy to release the crew. And then if it's smooth outside, there's not like some thunderstorms around, and the attitude of the aircraft is in a sensible one, all we do is we press the attend button, and that alerts the cabin crew that it's now safe to unstrap from the seats and start the service. So we might, if we have, say we're departing out of somewhere like Turin, which is right in the foothills of the Alps, the Italian Alps, there's huge amounts of high terrain. I think the closest, literally within 15 miles, 10 miles of the airport, the minimum off-route altitude that we can fly at is like 17 or 18,000 feet. It's really, really high terrain. And our aim, because we need to cross the Alps to go north, is to get altitude, get as high as we can, as quickly as we can. So we generally keep the speed back. So we get our flaps up, no lights. We'll keep the speed maybe at 220 knots, full thrust, and get the aircraft climbing up. But the thing then is your attitude, the nose attitude is actually really high. Could be close to 15, 20 degrees again if you're light. So that would not be, even though it's smooth outside, we're above 3,000 feet. That's where we would probably hold the cabin crew in their seats until we get to a good enough height that we're happy to start accelerating. The nose will come down and then we release the cabin crew. So yeah, good questions. Hi, Simulated Gamer Susie, welcome to you. Video as well. John, hey John. Hey Andrew, how are you? So it says, I know that 737 is a model that do not include the EICAS system for engine indicator and crew alerting like the 777. May I know more about the procedure of how the crew monitor when there's a failure without an EICAS system, say an engine failure? Will the procedures be a lot different if it was implemented into 7.3? So yeah, it's an interesting topic that actually, Andrew, because most aircraft now have EICAS, which is engine indicating crew alerting system, which kind of on here you'll get alerts pop up. Now on the 737, that was kind of preceded, if you like, by our master caution system. So in an EICAS, these kind of alerts would actually be electronically displayed on the upper DU normally, or the lower DU. And we, in the 777, you can see that, if you're going from a 737 NG to a 777, the transition is relatively straightforward. Everything kind of looks very similar, but they've implemented a lot of these systems into the DUs here. So you can actually see the fuel system down there rather than having to look at the diagram up here. It kind of is down here. So generally speaking, if we get a problem, rather than the EICAS system popping up, it will pop up on our master caution system. So it's a very simple system, but it's a classic case of if it ain't broke, don't fix it. Because there was a lot of talk that in the MAX 10, that the MAX 10 would have to implement EICAS, and that would require a lot of recertification, a lot of retraining. And Boeing made a case to the authorities going, look, there's no history of aviation incidents where the lack of an EICAS in the 737 made it worse. Pilots are very familiar with it. Let's just keep it. And the FAA and the various authorities actually did agree that that did make a lot of sense. So we don't have an EICAS system. We have the master caution system, and it works in a very similar way. So if we got an engine failure, for example, we would see as the engine failed, obviously the electrics would trip off because that engine is no longer tripping. Master caution, and you get an elect light come up. You'd also feel the yaw. You'd see the aircraft, trying to counteract that, and then you get some other master cautions as well. So that's generally how that manifests itself. So that's an interesting question. Let's have a look. So Umberto, hi. Why don't you use VNAV takeoff as Boeing suggests, but level change until bug up? Yeah, you can do VNAV takeoffs. You can arm VNAV for takeoff, and it's certainly something that you can do in the 737. It's just something that I don't think many European operators do. I've seen operators do it in the States. There's VNAV. If you use VNAV, it's taking data from the FMC, and takeoff is a critical phase of flight. And when we don't necessarily go into level change, we go into TOGA mode. So by pressing TOGA, what that will do is effectively set takeoff thrust and then climb to maintain a speed of V2 plus 20. And then we bug up. And if we use, there's a potential downside of using VNAV too soon, because VNAV, if you've got a speed restriction in a turn, say you have to go around a bend and there's a 200 knot speed restriction in the turn, and for some reason it drops out of that, or we forgot to put it in, VNAV will command faster than that speed restriction. without us doing anything. It would just automatically bug a faster speed. Whereas if we're out of VNAV, we're more in control of the aircraft and we are aware of the speed restriction, so we won't bug it. So I think there's pros and cons of both. You can argue it either way, but I've flown the 737-300 for KLM UK. I also was trained on with Australis years ago before that. I'm now with my current airline, and they've none of them have used VNAV for takeoff. So I think it's just horses for courses. One isn't definitely better than the other. It's just different ways of doing it. But it's an interesting topic. Alessandro, hi. When does the flight director transition from this logic, which I guess is TOGA, to a normal flight? Pardon the term. No, not at all. And which mode does it engage? Good. So yeah, when we press TOGA, it will engage in TOGA mode. So it will give you the N1 thrust. It will give you TOGA pitch, which, as we said before, pitches us to maintain V2 plus 20. So 146 plus 20, 166, up to a maximum of plus 25. And it will generally stay in that mode until it changes, goes into a different mode. So either it levels off, in which case it will go out of quiet and out hold, or we engage in other modes. So if we're continuing the climb and we keep climbing up, we would, until we engage VNAV or level change, then it will take it out. But otherwise it will stay in TOGA mode until the aircraft levels off or we change it effectively. Good. So I'm just going to catch up with a couple of questions that from people that can't make it live today. And one of them was the anti-ice. When would you put the anti-ice on? So we've got the engine anti-ice and we've got the wing anti-ice. So engine anti-ice and wing anti-ice. So to turn them up, to turn the engine and wing anti-ice on, we move the start switches to continuous to give us a bit of protection for the engine. And we've turned the switches on, and they should go a bit like the valve we spoke about, the crossfeed. It's the same logic. They go bright blue when they're in transit, and then they go dim blue when they're in the commanded position. So when we turn this on, we should see the light go bright blue and then to dim. So bright blue, dim, bright blue, dim. That means they're now open. And on here, you'll see TAI, thermal anti-ice is on. Now, we would turn those on when a certain criteria are met. And that criteria is when we have visible moisture outside. So in other words, there's rain, there's snow, there's sleet, there's hail. All the visibility is less than 1.6 kilometers, less than a mile. And we have standing water, snow on the runways, taxiways. So if it's 10 degrees outside air temperature or below, with any of those conditions, we would put the anti-ice on. And you might go, why at 10 degrees do you need anti-ice? And the answer for that is that air is getting sucked into the engine. And as air is getting sucked in, the pressure drops. And you've probably seen on some of these great YouTube videos of aircraft getting airborne in like humid conditions, and you see this vapor in the front of the engine. And that's because the pressure reduces as the air is getting sucked in. And as pressure reduces, so does the temperature. So although the outside temperature can be 10 degrees, when it's actually entering the engine, because of that pressure drop, it can actually go to sub-zero. And moisture can start freezing straight onto the cowl, the beginning of the engine. So we protect that by putting it on. So that's when we would turn it on. And wing anti-ice we would put on if we see actual airframe icing building up on the aircraft. And a great place to look for that is, if I just raise up, is on the other pilot's wiper bolt. So if I scroll on here, so as you're flying along, if you're in ice cloud, you'll start to see ice film on the very front of this. Your one's not so good because you can't see the front of it. You can only see the back and the side. But if you look across at the other pilots, you can see the front of their bolt here, and you'll see ice getting built up. And you'll also see it start to form on the windows. And the best way of having a nice clean wing is allowing the ice to build up a little bit, which feels a bit weird. So you let it build up. And then once it's built up, you turn the wing anti-ice on, and then that will send heated air to the front of the wings, and it breaks the ice off. And that will give you a nice clean wing. So that's when we would use that. So that was a good question we got from some people who can't make it live. I'm just going to have a look at a couple of other ones here. So Greg asked, who's over in Australia, I believe. He's ground crew there for 20 years. And he was saying that when we started the engines yesterday, we count to 15 seconds before we count to 15 seconds after moving the start lever to idle. And he's saying that from a dispatcher's perspective, when he's on the ground, if fuel doesn't ignite, you get like a white plume out the back, which you can sometimes get when it does ignite as well. I'm curious what happens from the pilot's perspective in the flight deck if this happens. So it's a good question from Greg. So you remember we go to, when we're starting engine, we go to ground, we're looking for 25% N2, and then we bring the start lever to idle, which brings in fuel and ignition. And there's a 15-second timer that we have to make sure that we comply with. So in other words, we need to make sure that we get ignition within 15 seconds of moving that start switch to idle. So you can count 1001, 1002 in your head. Obviously, we start the stopwatch as well to, when we start the engine starts, we can keep an eye on it. If you're like Lulu, you can start counting in bananas, 1 banana, 2 banana. I know Lulu loves the bananas, but 15 seconds. And then if a few things don't happen, we would move the start lever to cut off. So if we don't get a light up in 15 seconds, we would move the start lever to cut off and go into the aborted engine start memory items or process. Similarly, if you bring the start lever to idle and the EGT starts increasing really rapidly, because you get a feel for what a normal acceleration looks like, and if it starts to accelerate really rapidly, that could be an indication of a hot start. So it's getting too hot in the engine, and again we would move that to cut off. And what can sometimes, because the starts are being monitored by the electronic engine controller, it will make these boxes flash yellow for 10 seconds and that'd be a good indication to turn it off. So generally speaking, to answer that question, if we had like a hung start, which is where it won't ignite, you'll see that we have N1, we have N2. You might see a bit of a rise in EGT and fuel flow, but it's going to be very negligible. It will just kind of hang there. I've had it before. It's quite rare, but you kind of get to that 15 seconds. It's not really accelerating, and then you would move it to cut off. So that's a good question. Oh, hi, Paul. Yeah, reminder. Thank you for the reminder. I DM'd you about the differences between the 800 and the other variants, the 600. Yeah, so Paul asked a good question because when he was following us along and we were doing the zero fuel weight, if I just go in here, we were putting the zero fuel weight in at 59.5 and Paul was following along in a 600 and he was saying that it wouldn't accept it. And that's because the 600 is quite a significantly smaller aircraft, and the zero fuel weight limits on that are different. So the zero fuel weight limit on the 800 is 61,688 kilos. So just under 62 tons, but on the 600, it's lower, less than 59.5. I don't know off the top of my head. So it basically wouldn't allow Paul to enter 59.5. So the differences between the 6, 7, 8, 9 are very marginal. From an operational perspective, they're very, very, very similar. Even like flying the MAX, when I'm flying the MAX, from a day-to-day operation, it's very similar. But there are some differences in the sense that the zero fuel weights, again, are higher on the MAX. The landing weight, takeoff weights are higher on the MAX than they are on the NG. So they're the main differences in the variants. So if you're flying like a 600, you just have to put a slightly lower weight. So in other words, because the aircraft is smaller, it weighs less. And because it's got less seats, we can't put as many passengers in it, which means that the maximum zero fuel weight of the aircraft just has to be less because, there's only so much of an aircraft and so much we can put in it. So it will be less than the 800. So it's just a matter then of finding a load that will work. And the best way of doing that, Paul, would be to go into SimBrief and generate a flight plan. And you can put how many passengers you want, or just go full, half full, how much cargo you want. And then it will generate a zero fuel weight on that flight plan for you. And you can enter that into the FMC. So that's a good way around it. So that's a good question. Oh yeah, Lulu's remembering my trip from Edinburgh to Prestwick to Edinburgh to Prestwick. Yeah, it was a long old day. So Vincent, thanks for answering my question. My pleasure. I always seem to have an issue switching the bus from the ground power to the APU. As power seems to cut out temporarily, but not sure if this happens in real life. So not really. So if you've got the ground power on and we've just started the APU and this light then comes on, and this light here tells you that the APU is now available to supply electricity to the aircraft. So we start the APU, we wait for that light to come on. When we then put this on, and that will disconnect the ground power and connect the APU power to the aircraft. And there is a momentary disconnect when they transfer, because in the 737, one of the basic electrical rules of the 737 is you can't have two sources of AC power powering the same bus at the same time. So if we want to have the ground power, which is powering it at the moment, and then we want to now transfer that over to the APU, we can't have the ground power powering it as well. So it has to disconnect the ground power first. And it does that automatically when you move the switch to on. But there is a split second where the ground power is disconnected and the APU hasn't yet connected. But it's a very split second, and it shouldn't cause anything to trip off. Occasionally, you'll see the voice recorder switch trip off. That's probably the only thing that you might see that trips off during the power interrupt. But otherwise, it might just be a sim thing. So it shouldn't be an issue for you, Vincent. But if it does, just pop them back on again. Marcus, hi. Is there any difference between the engine startup procedure if an air start unit is used instead of the APU? Yeah, there is quite a difference, actually. And that's something we're going to be looking at in the future is if your APU is not working. So like we said, when we first get on the aircraft, one of the first things we do is check the tech log. And in the tech log, it will tell you if anything is not working that day. And occasionally, the APU might be inop. In other words, it's not working, which means we don't have a source of air to come in and pressurize the starter system to start the engine. So to get around that, we have an air start unit, which is basically a giant kind of compressor. They're huge. They make an awful noise. They scream. And they plug this big yellow hose into the belly of the aircraft, and it pressurizes our pneumatic system that allows us to then start the... That's really weird. Why has my engine 1 just failed? Kind of failed. How strange. Lucky we're not going flying at the moment. Yeah, we've got N2, but not N1. Let me just see if I bring thrust up. Does it do anything? No. Okay, that's strange. It looks like it's kind of running down here, but we're not running. Anyway, we'll glance over. That's got to be a sim thing. Yeah, they plug compressed air into the aircraft, and then we use that to start the engine as well. It is a different process. We start a different engine first, and that's something we're looking at in the future, actually. It's quite a big topic, but there is a difference, yeah. Hi, Rex. How are you doing? German St. Peter, morning to you. Hey, Afnan, when to use anti-ice? Hopefully you caught my answer on anti-ice there. Hi, Chris. Greetings from San Francisco with a strong cup of coffee, Michael. Hats off to you. San Francisco, what are you, 7-8 hours behind? So that is, yeah, hats off. Great to see you here. Linus, hey, Ben, I have a bit of a meta question. Do you and Petter feel like you get anything out of this course yourself, whether it's insight on how to convey this to the general public? Well, Petter and I, as you probably we are kind of av geeks at heart. We love everything to do with aviation. If you look at his YouTube channel and the way he talks about that, if you look at my Instagram channel, any excuse to be involved with aviation is enough for us to get involved. And one of the things we did run this before back in February, March time, and one of the things, it's like a trial. And one of the things that we found is that, and one of the things that we both love about teaching brand new pilots, like when we've got cadets on a type rating course, is that enthusiasm. It kind of reminds us. I know what I was like when I was using the sim, because I had PMDG when I was first starting out. I mean, that was back on Flight Simulator 2000, I think. I think there was the original PMDG on that, or maybe it was FSX, I can't remember. And, I hadn't a type rating yet, and I just had this hunger for knowledge. I just wanted to learn. And I only got the enjoyment out of it when I knew that I was doing it as realistically as possible. I didn't want to just bumble around. And I see that reflected in so many of you. And I think it reminds Petra of ourselves, 20 years ago when we were learning and we wanted to learn more, with that hunger for knowledge. We wanted to keep getting better. I had that hope of flying the 737, and I wanted to just learn. And when I'm surrounded by people like we have in this amazing group here from all over the world with different backgrounds, different experience levels, from people literally just starting out that maybe don't even have a sim yet, but all the way through to actual pilots that are flying the line, and everything in between, from amazing homemade sims to people that have been simming for 20, 30 years. There's one common thread through all of that, and that is that love of aviation. And I think that kind of unites us. Doesn't matter where we are in the world, what culture we're from, what experience levels we're from, it kind of unites us on an equal ground. And that, I think, for me and Petter, is a big motivator. We love kind of getting involved with that. So I think that's a big one for us. So Harry, please review bug up process. It's new to me. So bug up, I know it's a strange term, but we use anything we see on here is called a bug. And it goes back to the days that when we were flying the 300, we'd actually have actual dials. Like, for example, we have a circular airspeed dial with an actual needle, not a digital one. and we would bug like our V2 speed, and they look like little white, they could slide around the perimeter. So imagine this clock here was our airspeed indicator. It's like a dial, a real one. You'd have a perimeter and you'd have little white kind of like oval shape plastic that can slide around, and we could highlight a speed with that. We'd have different number of different bugs. So we could put one for our V2 speed, one for our up speed. And the reason I think they're called bugs is because when you look at them, they kind of look like little bugs. And that term is translated through to digital flying as well. So you can see on here, we've got this magenta speed bug. So whatever I set up here will move this bug here. Now, it will only show, you can't see 146, so it just parks at the top at the moment, but it's bugged at 146. And all we do when we get to 1,000 feet above the ground on the takeoff, so 1348 on the altimeter, what we do is we move this airspeed bug until this one here goes to where it says up on our speed tape. And that is basically our minimum speed where our flaps can be up. So at 1,000 feet, you bug that little magenta bug to where it says up, the aircraft will pitch down, and we can start accelerating and bringing the flaps up. So yeah, it's a good question. Yeah, we had a bird strike on the way back from that. Had a bird, quite a big bird, just on landing, coming into Stansted. Just as we're in the flare, this kestrel sort of darted around and bounced off the front of the nose and went down the engine, unfortunately. It's a beautiful bird. Shame the 737 won, but it was a shame to see the bird go down. Vincent, I've always wondered about the aircraft. Can it be set up to fly from a cold, dark setup if ground power is not available? The answer is yes, and it does happen. Occasionally we will, hang on a minute, let me move that back. What occasionally happens is, particularly if you're going from a small base or somewhere like that, where they don't have ground power, and you'll get on board, it's completely dark. And the way we would do that is do the bell check. So battery goes on, electric hydraulic pumps are off, landing gear lever down, check the ship's library. And then we would do the fire test. So we check that it's safe to start the APU. So we do the fire test, but we'd only get 10 lights when we do that, because the wheel well light, as we spoke, I think it's in yesterday's Q&A, the wheel well light comes from the AC power, whereas at the moment we're only on DC power. So we'd only get 10 lights. And then we would start the APU. And when we start the APU, then we get the blue light on, we can put the APU on the bus, and the aircraft comes fully alive. So it does happen, yeah. Can you, good one, Andre, yeah. Yeah, so Chris has come up with a good question, actually. How do you know how far to push the thrust levers to get a certain amount of thrust? Are there any markings on the throttle? No, there isn't actually, and you kind of get a sense for it. You kind of, it's like anything, I guess. You kind of get a feel for what you're going to do. So when we're coming to set takeoff thrust, we go to 40% first. In real life, I know how far to move that, so that straight away you can see the cursor goes to 40%, and it will start spooling up to 40%. You really just kind of get a feel for it. There's no markings on here or anything like that. It's just a rough thing. But for things like go-arounds, we just teach to press TOGA and then just give a straight arm. And then you put both hands on the control column. And then you'll say, go around, flap 15, set go around thrust. And go around is something we're going to be looking forward to looking at in the future. But it's an interesting one. Linus, what about the different climb? You got different climb, which I can't show you on here. But if I go, you got climb 1 and climb 2. So these are automatically set to give you, when you go to 1,500 feet, the thrust will come back to climb mode. And we've got climb 1 and climb 2. So full climb, 10%, 20% reduction. And you can set that so it will reduce the climb mode. So we can manually set those, but normally when you set a thrust on here, it will automatically give you the most appropriate reduced climb thrust as well, again, to preserve the engine. Okay, let's have a look. Cap 413. Oh, Guillermo, thank you for 3. Perfect, thank you. Okay, interesting question here. Someone said, what's the light grey button, intervent button? And that, actually, this one here is actually not a button. It's actually a light sensor. So around the flight deck, there's a variety of light sensors that sense the ambient light in the flight deck, so that the system can automatically adjust the brightness of all of the lights in here. So there's a number of them actually. You can see, look down here. There's one here, there's one here, there's one here, and there's someone out, there's one here on our FMC. And what it does, there's some on the front as well. So if I kind of lift my nose up, these little things here looking forward, there's a number of light sensors, and the system takes an average of all of them. So for example, in the morning, it might be relatively dark, the sun's coming up, and as you turn, you'll see the sunlight shine in across and illuminate the whole center pedestal, the center instrument cluster, and you'll suddenly see the brightnesses all come up to enable us to see the instruments clearly. So it's actually a light sensor. Jan, my question was on the fixed lights. Do you keep them on until you have left the TMA? Oh, okay. So the fixed landing lights, after takeoff, we turn these off once we climb through 10,000 feet as part of the 10 checks. So these come off 10,000 feet climbing as part of the 10 checks. Yes, Paul, you're correct. Hopefully I answered that on that. So Paul's asking about the bug up. Yeah. Shabib, so we're talking about igniters now. We got igniters for the engine. So here we've got the igniter system. Right, both left. We have two separate, like we do in a lot of things on the aircraft, there's a bit of redundancy built in there. We have right and left. So we generally start on the right igniter first because that's powered by the standby AC system. So if we had a double engine failure and we want to be able to relight the engines, we need the standby AC power to start the igniters. So as a safety thing, to make sure that's working, we always start on the right one first. And then when we get to a destination, we'll flick it over to the left one. And when we come back, we'll flick it onto the right one. So we're equally using the igniters. That's generally how we do that. Paul, can you zoom in to show the bug? I can't actually because we're not flying at the moment. So what are we doing? We're about an hour in. Should we do it? I have to restart the engine. Let me just see if I can restart the engine here. I'm just going to do a bit. This is very non-standard, guys. I'm just going to be a bit naughty and just to see if I can restart. For some reason, that engine has died, and I have no idea why. Okay, let's do something else. Let me just go into. I'm going to see if I can get this airborne because I just want to show you the bugs. So if I go to, can I go to? I'm not sure I can actually. What I might do, I'll be naughty. This probably won't. This is probably going to end in disaster, but I'm just going to do it anyway. I'm just going to get us airborne. I'm going to zoom us up. This is probably the quickest way of doing it. It's going to go horribly wrong to start with because we've got one engine working and we've got no airspeed and the gear's down and the flaps out. But I'm just going to show you, I'll try and recover it, and I'm going to show you what the speed bugs look like once I get it under control. So if I just jump in now, so I'm going to get the gear up and get the flaps up. Now, I've got it in freeze at the moment, so hopefully that'll work. Now, the bug, if I zoom in on here now, this is my speed bug control, and you can see that as I bug up, you can see, let me go in the wrong way, hang on. You can see it moves this bug here, and there's the up bug. So we move, when we say bug up, we move that bug till it goes to up, and then the aircraft will pitch down and then begin accelerating through flap 1, through flap 5, flap 1, flap up. And that's now our up speed. So that up speed there is our minimum speed with our flaps up, basically. So hopefully that works. Tom, hi Tom. Can you use derated climb thrust as well as derated takeoff thrust? Yes, you can. Absolutely right, you can. Linus, regarding the seatbelts, how often do you forget to turn them off? It can happen. Like sometimes if you pop out to the toilet or you've been through a bit of turbulence, you put the seatbelts on, and if you're busy, you can forget to turn it off. Generally, what I do is I use this little grab handle here. It folds down. You can press it. I don't think it works on here, but you can fold that down, and it's in your field of view, and it just my aid memoir to remind me that I've forgotten the seatbelts or something like that. So I just use that as a bit of a reminder, but it can happen. Yeah. Giuliano, hi. As a Boeing 737 captain, you're quite familiar with the VMO MMO pointer, barber pole on your airspeed indicator. Could you share a specific situation from your flying career where your attention was drawn to the barber pole? How did you handle that moment to ensure safety of flight? Okay, so this is the barber pole that Giuliano's talking about here. And occasionally, if you're in the cruise and you're really high level, you can get to a place that's close to what we call coffin corner, where we have our maneuver margins very close. So we can be very close to our maximum speed and are very close to our minimum speed as well. And I've been in a situation before where we were fairly, we had about a 20 knot below the max, but then we went into an area of a jet stream where the wind changed very rapidly and a headwind change, and that caused the speed to suddenly accelerate, the airspeed to suddenly accelerate, because we're going at, Mach 0.78, for example, and all of a sudden, as we go into the jet stream, the airflow increases, which has the effect of increasing your airspeed. So the best way of dealing with that, if you see yourself approaching that like we are, exactly as we are here, Boeing's recommendation is partial speed brake. So just not all the way, but just, if I can do it with this, my little lever here, partial speed brake, and that will just increase the drag and just allow it to slow down. What we can do as well is just maybe override the thrust levers, auto throttle, maybe by about 10%, and that can help reduce it as well. What we don't want to do is close your thrust levers at high level, because if you close your thrust levers at very high level, the spool up time to go back from idle back to a cruise thrust can be a very long time. It can be 20, 30 seconds. So all of a sudden you can go from a high speed event, you close your thrust levers, suddenly now your speed starts dropping off very quickly, and you add thrust again, but it takes forever for that to slowly start spooling up, and you can actually get into a low speed event. So we wouldn't close the thrust levers. So that's a good question. Tom, hi Tom. Do you think you'll be flying the MAX 10 in the future? Yeah, the company that I fly for has got a delivery of them coming. It's going to be in a couple of years by the time we get them. I think it's 25, 26 possibly. I think we're getting the MAX 10s. So looking forward to flying those. I think they're going to be very similar to the 8200s that we have at the moment, just obviously longer and a slightly different undercarriage. And they do come with the touchscreen FMCs, which I put up on my Instagram. What's my opinion? I'm not sure. I haven't tried them, so I don't want to jump in too quickly. One concern is that there's a couple of concerns for me is in turbulence. I've got a feeling it might be quite difficult to hit exactly what you want. Because on this, obviously, you can rest your hand on it, on your buttons, and feel them, whereas on a touchscreen, I don't think you can do that. The other concern is fingerprints, because obviously our fingers are oily, and if you touch a screen, when the angle of the sun is at a certain way, it just shows all the smears. So whether they've got some kind of coating on that to help prevent that, I don't know. But I also know that a lot of business jets do also have touchscreen, and it works really well. So I think it's one I'm going to hold judgment until I actually try it, I think. So hi to everyone signing in. So I'm just going to fast forward a few bits on the chat. Let's have a look here. Greetings from Malaysia. Hey, Terry. It's good to see literally a global group. It's amazing. We're talking to people from San Francisco to Australia to Malaysia, Europe, UK. It's great. Sean, I actually find I actually learn more when I'm teaching. Yeah, and I think I say it's a lot actually. When I became a flying instructor before I got into the airline world. So I did all my ground school, did all my my CPL, and all the bits that you do to become a commercial pilot. And then part of the deal was that the airline that I was going to wanted some hours to become before you actually join the airline, and they give us all an instructor rating, and they make us work at one of the flight schools for 2 years to build 1,000 hours before we join KLM UK. At the time, you're like, I just want to get flying big aeroplanes. But actually, I soon realized that flying instructing was such an amazing start to the career. I felt I learned more as an instructor than I did doing my CPL IR. You learn more about airmanship, about making command decisions, about dealing with problems, and just general flying. So I think, when you're teaching it, you generally tend to learn more. I agree with you on that. So do you try and avoid doing the fire warning or GPWS test during boarding? Yeah, it's something I am very aware of. So obviously, if we're boarding, we've got the door open here. Not so much the fire test, because maybe they might not know that, but we do a GPWS test, which is over here. And when you press that test, it will start shouting and doing a self-test. So it will go, too low terrain, whoop, whoop, pull up, and start shouting, and go wind shear, and start shouting all of these things as you start to test various systems. And I am very aware that as you're boarding an airplane, to start hearing whoop, whoop, pull up probably isn't the most welcoming thing you can hear when you first step on an airplane. Also being mindful that a lot of people are quite nervous. So I do try and time that for when passengers aren't near the front galley, or if it's inevitable, I'll close the door. So yeah, it is something I'm mindful of. Let's have a look. So hi, Greg. Welcome to you. Vincent, thanks again for all this amazing information. I had no idea how realistic my PMDD 737 actually is. It is mind-blowing. I think I said it before, actually, that if it wasn't as realistic as the real thing, Petra and I could not do what we're doing, because we keep hitting all the time. It is mind-blowingly good. Is it interesting? It's interesting the FMC gives a precise trim figure for takeoff, yet you do not get a precise gauge on the wheel. Yeah. So I assume in real life, the precise trim figure is not critical. No, it is very, very basic, as you can see here. You know, it'll give you 6.09 as a trim, for example, for takeoff, but we can't set, put a 0.1 decimal place accuracy on here. So we set it roughly. And thankfully, the 737 is quite forgiving. This green band here is your takeoff band. And even if as long as you're in that green band, you're probably going to be able to rotate quite happily. It might feel a bit stiff if it's too far forward, or maybe it might come up a bit quickly and you'd have to correct if it was the wrong. But, generally, if you're ever not sure, if you don't have a performance tool, I always say for home simming, if you just set 6 units of trim for takeoff, you're going to be very much in the ballpark and you're probably not going to notice too much. So if you ever want to calculate a takeoff, so if you go 22K thrust setting and you set 6 units of stab trim, for most airports for a home sim, that's going to work really well. So yeah, it's pretty bang on. Let's have a look. It says, hey Ben, a few minutes earlier, we witnessed 73 ascending up from the runway with 600 minute level altitude, how often does that happen in real life, and what flap setting? Hi, Aiken. Yeah, so if you missed the beginning, I actually spoke about an example where that happened to me, where we positioned an aircraft empty. And back in the day, this was years and years ago, where if we were empty, we go full thrust. And we're on runway 04 in Stansted. And it was years ago. And I remember we got airborne, rocketed up, and we actually got to our stop altitude on the SID of 5,000 feet before we got to the end of the runway. To the point when we were going up like a rocket, ATC even said to us, "Are you definitely leveling off at 5,000?" And we're like, yeah, we are. So yeah, it doesn't happen often, but if you're very light and you have a very high thrust setting, you can go up like a rocket. You really can. Andrew said that, Alessandra is saying that once you're sitting in right at the front, seat 1C, and the person sitting near me was not amused with the config check. Yeah, you hear all these weird noises, don't you, coming from the flight deck? The config check sounds like a bad thing. Mac. You might get all the tests, the fire tests. It can sound a bit worrying if you're a bit nervous, but it's all very normal, something we do every day. But yeah, I think as a good crew, just be mindful of that. David, hi David. Is there a situation in which you would use both igniters? In heavy precipitation, we'd move into flight, and by going into flight, that will automatically arm both igniters. So that just gives you both of them going to really protect the engines. That's a good question. Carlos, hi. If flight director is master on captain, should the FO override it? Should need be? So not really. So when the flight director will go on the same side, we've got a master and a slave. Now, if I go into command B, it will automatically give the autopilot the master on the FO side. If I go back to command A, it will change over to master on this side, and that light goes out. So whoever's pilot flying will have it as the master, but in reality, they're both cross-checking each other, and they're both very, very similar. So it doesn't really make too much of a difference. The only time it'll make a difference is if we start having problems with our instrumentation, like an airspeed unreliable and non-normals and so on. So generally speaking, you would just leave it with the autopilot. Oh, you're joking about the PMDG teleportation. Oh, I'm sorry. I thought you, yeah, when Aiken was talking about seeing an aircraft going up at 6,000 feet a minute, I thought you actually watched one out the window. No, yeah, that's something that would be quite handy in real life, wouldn't it? To be able to just go, yeah, we're a bit high on profile. We're just going to drop like an elevator. Yeah. Sorry, Aiken. But yeah, you're absolutely right. So question, I had an interview at Aviodrome, an aviation museum here in the Netherlands, to volunteer with their sim pits. Next week, I am flying in their large simulator with the 737 pilot. The sim itself is generic in hardware, full size enclosed cockpit, including even a jump seat. But simulating 737, I'm somewhat nervous and imposter syndrome, which I understand. Do you have tips on how to leave a good impression with the trainer without being a bit much? I think generally, if you're just keen to learn, if you're going to be with an instructor, you know, obviously, I think everyone here I can see, just kind of be humble, don't pretend. You know, it's better to kind of under promise, over deliver, isn't it? To kind of go in there and go, look, I'm so keen to kind of learn. You know, I've got a little bit of an idea, but I'm really keen to learn. And asking questions is a good one. Sometimes it's rare, but I remember when I was an instructor, you'd have people that might be learning to fly because they just want to say that they're a pilot or something. And you're telling them something, right? Trying to give them these real gems that will really help them. And you can see they've got not much of an interest. And as an instructor, if you think, well, if you haven't got really an interest, it demotivates me to start giving, every bit of information I can to try and help you. So yeah, just be yourself, be keen, be enthusiastic, ask questions, be eager to learn, admit mistakes. Oh, I wasn't sure about that. That didn't go as well. What could I do differently? Those are all great things to do, but I'm sure it'll be fine. It sounds fun. Keep us updated with how that goes. Let's have a look. So we'll do a few more questions before we wrap up and get ready for tonight's big session tonight, which is one of the biggest ones of the week, actually. So Linus is talking about what we call recycling flight directors. That's not a thing where we try and be green and save the planet. Recycling the flight directors means when we disconnect and we start flying manually, if we're going to recycle, we're not going to use flight director guidance, because there could be a number of scenarios where we might do that. If we're flying a certain non-precision approach, a visual approach, for example, we're flying visually, we're not following our instruments. So what we do is to recycle them, we turn them off together, and you see they disappear, and then we turn them on. Hang on. The only way to do it, let me just disconnect, and let me just put it back on again. So we would disconnect the autopilot, and then we turn them off, and then we would turn them on again. And you can see we don't have any flight directors active now. There's nothing on our display. But what it means now is that they are armed, so that should we need to go around or we go into another mode, we can press TOGA and they would instantly pop up. So if you disconnect the autopilot, you turn them both off, you turn the one on who is ever pilot flying first, because that will be the master, then the other one. That means they're now armed and ready to go. So that's how we would recycle the flight director. Hi, so Brian, why is the engine's performance reduced when ice protection is on? That's a really good question, because when we put the ice on, what it's doing is bleeding air out of the engine, hot air from the compressors, and sending it to the cowls or the leading edge of the wings. So if you imagine you've got air coming into the engine, that's being squeezed, we're igniting that, or mixing it with fuel and igniting that, and that's sending it out the back, which produces thrust. If we now take some of that air out to go to the anti-icing system, that means we have to reduce, to keep the mixture of fuel and air correct, we have to reduce the amount of fuel going in. And if you reduce the fuel and the air going into the combustion chamber, we're not going to get such a big bang, which means we're not going to get as much thrust out the back. So by taking the anti-ice on, we are reducing it. And actually you can see, if I turn these on, you should see in real life the exhaust gas temperature rises slightly, because we haven't got as much air going through. So if I turn that on, do we see them go up? Maybe because, oh yeah, it went up, there you go, 691, 692. So again, this PMDG is incredible. So yeah, that's a really good question. Hey Bernadette, how are you? Good to see you here. Oscar as well, welcome. Thanks. No, Lulu says, be yourself unless you're me. No, Lulu, just be you. Okay, good. So Egan, so when you switch the flight control switches to standby rudder, does the associated hydraulic system keep supplying power to the elevator, ailerons, and spoiler in a situation where both hydraulic systems working perfectly fine and the pilot? Yeah, so up here, if I probably the best way to go. So if we go to standby rudder, we're basically turning off the hydraulics for our flight controls off, so we can turn these through to off and onto standby rudder. And what that means is that we open a valve, we close the main flight control shutoff valve, which isolates the system A fluid on that side, for example, to the flight controls. But we're opening the standby rudder valve. So that comes from a completely separate standby system to power the rudder. So yeah, if you go to system A off, that system A hydraulics can no longer power the flight controls, which means autopilot A would not be involved or be engaged. So yeah, but you're effectively turning that off. Let's have a look. Carlos, what could be the possible cause of when I take off the aircraft banks to either left or right while the control column is straight? That could well be your rudder down here. So remember on the before takeoff checklist and your flow, we finish on the rudder trim. So we check that this is 0. That's got to be 0. If it's not, you're going to roll when you get airborne. It could be thrust asymmetry as well. Just check your N1s are the same. There could be a problem with your auto throttles. Could be that, I'm not sure, but that's probably the one that springs to mind. So when you have a set max cruise setting and you push your throttle to full, do you get only the max cruise power? So if I just go up here, you can see actually if you increase thrust, it will actually go to the maximum thrust setting you can get. This is your cruise limit. This is your limit for the climb. And that's what the auto throttle will limit it to, but you can override that by moving the thrust levers yourself. So yeah, it can be overridden. Yes, Ben, the rudder. Yeah, the rudder. Yeah, Sasha and I were in a fixed base sim and we had some fun with the rudder, didn't we? Good. Hey, Jon, nice to see you here. Again, what kind of situation requires you to switch the bus tie breaker off? So the bus tie breaker, you've got the bus transfer switch here. So we can isolate because the power electrically connects from one to the other. So for example, if I just close that a moment, if I say, for example, the left engine generator, say the right engine generator fails, the left engine generator will flow across, there'll be a connector breaker that will close and allow power from the left generator to supply the right system. At the moment, the right engine is supplying the right electrical system and the left is supplying the left. So for example, that should show you, maybe because we're paused, I don't know. But yeah, if I turn this off, you'll see that this amber light will come on, but it will still be powered. It's probably because we're paused. There you go. So the source off comes on. So now it's being powered by the left one. And if you put it back on, it's now being powered by its own one. Now, the reason we might have to go to bus transfer off is because that was automatically transferring the power off. But if you had a problem with that, you might have to isolate. You don't want the good side having to sort of power a bad system. So the checklist would then revert you to going to bus transfer switch off. Maybe if we're trying to isolate smoke or fumes from a fire, we try and isolate. There would be a time where you would turn that off. Okay, excellent, guys. So that was a really fun session. Really enjoyed that. I'm really looking forward to tonight. So hopefully you can join us tonight. We're going live again the usual time, 1700 UTC. It's probably like the culmination of everything we've learned so far. We can piece everything together. We're also going to be doing you a bit of a max conversion. We're showing you the differences with the max start. We're talking about bowed rotor motoring, BRM, and the differences with starting the newer LEAP 1B engine. So yeah, do join us for that. It's a great session. And Petra and I are both really looking forward to seeing you this evening. If I've missed a question, I apologize. We are doing more Q&As coming up, so I will answer it for you. So please do let me know, and I will do my best to answer those for you. So just one quick one here. Jay, I don't want to miss that question. From a normal seated position in takeoff or landing, how far over the glare shield should you see? Looking for an eye view position in the PMDG. So what I would say, basically what we've got now, so you should just be able to see over the top of the glare shield, but not so much so that you kind of get this block. So you're not really flying like this because you kind of blocks a lot of like your flap views and stuff like that. So kind of where, if you're sitting where you can just about make out, I can kind of do it about there. That's pretty good, where you can see the top of your flaps, you can see all your instruments, and you can just about see over your glare shield. So you can see the little light sensor in your wipers. That's a pretty good eye position. That's pretty good where I would normally be, and that works really well. But thanks everyone for joining. Absolute pleasure as always. It's great to see so many of you, and Petra and I are super excited to see you tonight at 1700 UTC. Have a great day, everyone. See you all soon. Cheers now. Bye-bye.